Let's add a new Swift file to the project. We'll add it to our networking group, and we'll call this iTunes API Client. In here, we'll define the API client through which we'll make all the requests to the server. If you took the previous course on networking, we're not going to be doing much different here. The tricky part was mostly in creating the right kinds of URLs in a safe manner. So we'll start with a class, and we'll call this iTunes API Client. The API Client object will have a single stored property, an instance of JSON Downloader, which we'll use to create JSON tasks. So we'll say let downloader equal JSON Downloader. We're going to use the iTunes API Client in 3 ways. First, we'll conduct a generic search for a term entered in the search bar. Once the user selects an artist, we'll look up an artist, and then once the user selects an album, we'll look up the songs. Each of these are 3 distinct ways of using the API, so let's create 3 methods, starting with the generic search. We'll call this method search for artists and define a parameter to accept the search term. So we'll say func search for artists with term, and this is a string. We can't stop here though. Remember that any networking calls we make are conducted on background threads, and we can't return values. The only thing we can do is to define a closure that will be executed once the task is complete. For that, we'll include a completion handler as part of our method signature. This way, at the call site, we can define a closure indicating what we want to do with the values that will be provided as arguments when the network request completes. So second argument here called completion, and this is an escaping closure. And that's because this closure is going to be executed sometime after the body of this function has executed. What about the arguments to this closure? What are we eventually going to call this closure and provide? We'll be defining this closure at the call site, which means we either need the right kind of data back or an error. Now, in this case, since we're searching for artists using a term, the right kind of data on a successful network request would be an array of artist objects. And that's essentially how we defined our stub. The signature of this closure, therefore, is going to be, so in here, we'll include our arguments list that the closure will accept and a return type of void. So the arguments that this closure is going to accept that we'll provide when we call the closure is an array of artist or an iTunes error. And since that's an or, this is going to be optional. In the body of the method, we'll use the argument provided by the method to create the correct endpoint. We're searching here, so we're going to use the search endpoint and pass through this term. That way, all we need to provide at the call site is the search term. Our app is going to be restricted to music, so rather than configure that at the call site, we'll permanently provide arguments for the media, entity, and attribute values in here. So to create the endpoint, we'll say endpoint equal iTunes, that's our enum, and we're using the search endpoint here. We'll simply pass the term through that we provide when we call this method. And for the media type, we'll say .music with an entity of .music artist and an attribute value of artist term. Using this endpoint, we can now create a JSON task with an appropriate request. So let task equal downloader.json task with request, and we'll pass through the endpoint's generated request. And then we'll use a trailing closure here, and we're going to get back a JSON object and an error object. Remember, when we do this, all we're doing is creating a task. We're not actually starting it. So before defining the body of this completion handler to the JSON task, let's call resume on the task to actually start it. Okay, all that's left now is to define a closure indicating what we want to do with the JSON data that we get back, or in the event that it failed, the error object. From this point on, everything we do is going to be UI related. So first, let's jump back onto the main thread. So we'll say dispatch queue.main.async and pass some code. The JSON object provided as an argument to this closure is optional. So let's check to see that it exists. If it doesn't, that means we have an error, so we'll bubble it up to the call site using the final completion handler, this one right here. For the absence of the success case, that is, if the JSON doesn't exist, typically we'll call our completion handler and provide nil for the model value. In this case, though, the data we're returning is an array of objects. It doesn't make sense to have an array of nil objects or optional objects. So instead, over here, if we don't have data, we'll return an empty array. At the call site, when we define that final closure, we can check to see if this array is empty, and an empty array means an error. So inside this dispatch queue, back on the main thread, we'll say guard let JSON equal JSON else. So if this can't be unwrapped, if it's nil, then we're going to call the completion handler, and for the arguments, we'll say empty error, meaning no data, and we'll pass that error through. So we also need to return because we need to exit the current scope in a guard statement. Once we have a JSON object, once it's unwrapped, the next step is to parse that data and convert it into our model objects. When we poked around this data in Postman, you'll remember that for every type of request, the JSON response was a dictionary at the top level with a key results containing the data we wanted. The value for that result key was another array of dictionaries. Let's attempt to parse and convert the JSON to the array we need. So we'll say guard let results equal JSON, and we'll use the results key. And we want to convert this to an array of dictionaries, and we'll cast that as a type string to any. If this fails, we'll call the completion handler again and provide an empty array and error argument. Now, before we do that, let's define a new error value. So back in the iTunes error type, we'll add a new case. We'll say case JSON parsing failure, and we'll include an associated value, a message of type string, that we can use to provide more information about why the parsing failed. So back in the client, in here, we can say completion, empty error, and then for the error, we'll say .json parsing failure, and the message here is JSON data does not contain results, because obviously we could not unwrap it from this operation right here. As always, this is a guard statement. We need to exit the current scope. At this point, results is now an array of dictionaries where each dictionary contains data for an artist. To go from this dictionary to an artist is simple because we have an init method for that. We can handle it all in one go using the flat map function. So we'll say let artists equal results.flatMap. This accepts a closure that takes each dictionary and does something with it, and we'll use that with the artist type and the JSON initializer to create an artist object. So flatMap is typically used to flatten nested arrays, but in our case here, we don't have nested arrays. So why am I using flatMap? If you look at the type for the artist constant, you'll notice that it is an array of artists. If we change this function from flatMap to just map, what is it now? Now it's an array of optional artist. This is because the initializer we wrote that accepts a JSON dictionary is a failable one and returns an optional instance of artist. When we use the map function along with this init method, all the artist instances we get back are optional ones. FlatMap treats optionals differently. If we flat map over a collection and return an optional, as we're doing here, if the optional is nil, it is not included in the result set. If it isn't nil, it is unwrapped and added to the array as a non-optional value of that type. So in this way, even with a failable initializer, we end up with an array of non-optional values. Of course, there's a catch here. I'm going back to the flat map method. So there's a catch here in that if some of the data does exist, but we're using the wrong keys and our initializer returns nil, that means this map signature is just going to discard that and give us an empty array. But I know for sure that I'm using the right keys, so in this case, it's okay. Since this is our success case, let's call the completion handler and pass the artists array through that we just obtained and nil for the error. Let's test this out. When we type something in the search bar, we're going to call the update search results method, which we've implemented in the search controller, the search results controller. So in your controllers group, go to the search results controller, and down here you have this protocol method. And right now we're using a stub just to generate that fake data. So let's get rid of the call to update the data source with the stub data and use the actual client. So first, we'll need to add the client as a stored property to this class. So up at the top, we'll say let client equal iTunes API client. Back in the protocol method, we can call our single method to search for artists, and for the search term, we'll just use the search bar's text. This is an optional property, so we're going to force unwrap it. So we'll get rid of this. Actually, let's get rid of everything. And here we'll say client.search for artists with term search controller.searchbar.text force unwrap. And this completion handler gives us, I'm going to use a trailing closure here. We get either an artist object or an error object. And for now, I'm going to ignore the error. I'll let you handle that since you already know how. Inside the closure, we have to define what we want to do with the resulting artists provided as an argument to this closure. And we're just going to go ahead and update the data source with the new artists. Note that we're referring to self inside a closure that is captured by self itself, since this client object is a stored property. So over here, we need to capture self weakly to avoid a reference cycle. After updating the data source, we want to run through all the data source methods as well. So let's call tableview.reloadData in here too. So this self now needs a question mark. And in here, we'll say self.tableview.reloadData. Let's test this out. Let's run the app. And once this comes up, let's hit search iTunes, and let's start typing. And every time you type a character, we fire off a new request and get the artist, update the table view to display the search results. Pretty awesome, right? In the next video, let's tackle the next bit, looking up an artist once I tap on it in this search results controller.